Hello everyone. Today we are going to review writing, adding, and subtracting in scientific notation. We'll also go on to multiplying and dividing. So the first thing you're going to know is you're going to remember how to add and subtract numbers in scientific notation and have a quick review of how to write them. While you're doing this, take some notes in your composition book, follow along, watch, because you will need to do some work after this lesson. So recall that standard form is just a normal number. So I'll refresh your memory with that. Like 37,000 would be in standard form. Scientific notation would be when we take that decimal place at the end and we count backwards 1, 2, 3, 4 to get a number between 1 and 10. So in this case, 3.7. And then we had to count 4 steps back to get that number between 1 and 10. And it would be times 10 to the 4th. So this would be that same number in scientific notation. This is review, so that probably sounds pretty familiar to you. If you had a tiny number, let's say that we had the number 0.00029, you would do the same thing. That would be your standard form, and then you would count backwards to get a number between 1 and 10. So that number between 1 and 10 would be 2.9. So 2.9, and you had to count 4 the other direction, so it would be to the negative 4th. So tiny numbers have a negative exponent. Now, if we're going to convert back and forth, I just kind of showed that, but I'll pick a number. I'll say 16,244. And then I'll also say 0.01629. So those are our two numbers. So here we are, we're in standard form, a normal number. We have that imaginary decimal point at the end. It's not really imaginary. There's 2 zeros that would go after that and so on. And you're going to change it to scientific notation. So you have to move back to a number between 1 and 10, and that would be 1.6. And I'll include the 2 just to be out to the nearest hundredths, times 10 to the, and you count how many hops it took you to get there. So 10 to the 4th. It's a big number. It's bigger than 1, so it is a positive exponent. Now here, you have to count till you get a number between 1 and 10. So that would be 2 hops. So that would be 1.6 times 10 to the however many hops you went. But because that number is less than 1, it's a negative 2. So negative exponent if it's a tiny number, positive exponent if it's a big number. I hope that sounds familiar. Now you have the opportunity to add. Now it might be helpful for you to have this quick memory that 4.01 times 10 to the 3rd is simply 4.01, move your decimal 1, 2, 3, so it would be 4010. Plus 2.415, you move your decimal 3 to the right, so that's really 2,415. So what you're actually doing, I'll show you off to the side, would be adding 4,010 and 2,415. When I do that, I end up with 6,425. Now, presumably they want that answer in scientific notation, so you would count your decimal point back to get you 6.4 times 10 to the 3rd. But that's a little more work than we actually need to do. What we actually need to do is simply grab our calculator or use our heads and add those two numbers together. And you'll come up with 6.425. And then because your exponents are the same, you can keep it the same, times 10 to the 3rd. Notice that these two are equivalent. I just didn't include all my decimals over here. Now with subtracting, it's the same way. So you can grab your calculator or you can use your head, and you can just do your 5 minus 2.57. So if you haven't gotten your calculator, please consider doing that because I'm not testing your subtraction. And you come up with 2.43. So I'm jumping straight to just subtracting 2.43. And as long as that number ends up between 1 and 10, you are golden, and you just keep your exponent. So times 10 to the 3rd. This probably feels very familiar. Now, sometimes it becomes a little more complex than that. So here we have 4 times 10 to the 3rd minus 3.39 times 10 to the 3rd. So do that out, and you come up with 0.61. And this is what I'm talking about, where this first number needs to be between 1 and 10. So right now you have 0.61 times 10 to the 3rd. okay? But this number is not between 1 and 10. So I'm just going to take you through the little steps that show what the shortcut will be. So if I say 0.61 times 10 to the third, that really means I move this 1, 2, 3. So if I move that 1, 2, 3, it would be the number 610. But in order to write it successfully in scientific notation, watch my hops backwards in red here, I would really have 1, 2. So this is 6.10 times 10 to the second. So when you have a number that is not between 1 and 10, you would say, well, I need to move this 1 to the right. And what will happen is this number will come down. So you've got 6.1 times 10 to the second. You may be somebody who does not want to memorize that or really can't memorize that, in which case this is the process you go through. I struggle to memorize that. I almost always go through this process. Now, our next skill, multiplying and dividing in scientific notation. Many students find this a little bit easier than adding and subtracting. Today, we'll review how to multiply and divide. Let's see. So we'll go through a few more examples. So with multiplication, it's actually pretty fun. You're really just multiplying that first number times the other first number. So my 2 times 2, we all know that that is 4. So 2 times 2 gives me 4. And then you are adding your powers. So you would say 2 plus 3 gives you 5. So this would be 4 times 10 to the 5th. As long as this first number is between 1 and 10, that is your answer. Now the y of it, some people will care about the y. This is really 2 times 10 to the second is really 200. 2 times 10 to the third is really 2,000. So you would say to yourself, 200 times 2,000 gives you 5 zeros, right? So if you have 5 zeros, now you count backwards, 1, 2, 3, 4, 5. So there you have 4.0 times 10 to the 5th. So if you wanted to do it out this long way, you could. I don't really recommend it. I think that it's a little more efficient to just multiply your first numbers and then add your exponents. You might remind yourself that I don't have. Our next one for division. This is where it gets a tiny bit tricky for kids. You want to remember you're not subtracting 3 minus 3, you're just dividing. 3 divided by 3 would be 1. So this would be 1, and then you subtract your exponents. That's your exponent rules. So 4 minus 1. So this is 1 times 10 to the third. You could say, well, I really have 3 followed by 1, 2, 3, 4 zeros, and I really have 3 divided by, or 3 times 10 to the 1, which is just moving over. So you would move that over your 1 decimal. And when you do that, you end up canceling those out. So you end up with, let's see, 3,000 divided by 3. So you have 1,000. And 1,000 would simply be 1, 2, 3. 1 times 10 to the third. I don't recommend this. The shortcut is so much better for you as far as time. Go back a couple of slides. Good example for this one. Now, sometimes it gets a little more complicated. Sometimes you have a negative exponent, and you have to recall that you're dividing these first two numbers. So you're really doing 7.8 divided by 2.5. So you might want to reach for your calculator for that. And when I do that, I come up with 3.12. Simple calculation. But here we're subtracting our exponents. So we would say 2 minus negative 1. Recall that minus a negative is the same as plus. So this is really 2 plus 1, or 3. So you end up with 3.12 times 10 to the third. Be careful with your signs. I'll star this. Be really careful. Write that out. You may have fallen for the 2 minus 1 and gotten 1. I'm showing up. And our last example is a multiplication example, and it will be the same in division, but you would still follow the same process of multiplying your 5 times 8. However, watch what happens. 5 times 8 is going to give you 40. That is not between 1 and 10. You will still follow your same process of multiplying your power, or of adding your powers, 10 and negative 3 gives you 7. And then you have to ask yourself, well, what do? I have 40 times 10 to the 7th. So you might remind yourself, just do it out our long way. So 40 times 10 to the 7th is really 40 with a decimal place here. if I'm going to go to the 7th, I'm going to count 1, 2, 3, 4, 5, 6, 7, and I'll fill in those zeros. Okay, so I have a very large number. Now I need to get back to a number between 1 and 10. So what will I do? I'll show it in green. To get back to a number of 1 and 10, 1, 2, 3, 4, 5, 6, 7, 8. So really my actual answer is 4.0 times 10 to the 8th. So when you have that number bigger than 10, you're going to grow your exponent. So that would be our reasoning behind this. Now, at this point, you're going to go on to your practice, so it is time to watch that.